liners, thank you very much for your visit to the channel Transmission Lines Engineering TV. This is the third chapter in this series named War in the World, in which we will talk about the electrical development of the Soviet Union. The Soviet Union, Russia, is a geographical area of great territorial extension, and precisely because its extension and its political position in the world, Russia is another country that also realized the role played by the electrification for the promotion of this country in manufacturing, national development, and military power, including space research in the times of the Cold War. In 1870, Russia began its interest in the application of electricity in a massive way for military purposes. The electrical development of Russia advanced slower compared with the Western societies. An influential factor in this development was the fact that Russia does not have the hydrological resources as other regions because it is located far to the north, and the lakes were subject to low temperatures almost all year round, like the Siberian zone, which led that the systems to alternating current in AC was not entirely an option, since it was not possible to build hydroelectric plants in those areas and take the electricity to great distances towards the centers of consumption. So originally it was opted for a system in direct current in DC, and even so, as in the United States, there were many technical differences in Russia regarding the transmission length efficiency DC versus AC. Towards 1882, the electrical bulb of Edison arrived in Russia. From 1886 to 1920, the first generation plants were erected in the city of St. Petersburg and Moscow. Later, before the beginning of the First World War, Russia began to plan an electrification program in the rest of its territories because of the threat of the beginning of this war conflict. Unlike the United States, where generation plants grew rapidly throughout the country, Russia, in addition of having few plants, its generation capacity was very limited. 300 megawatts in 1913 with 220 plants, compared with the United States with 5,000 megawatts in 1912 and 5,200 plants. In Germany, 2,000 megawatts in 1913 and 4,000 station plants. It was until 1886 when the German firm AEG, competition of Siemens, managed to develop the technology to reduce the high voltage of AC to levels of 120 volts in AC, making it safe for its final use. And it was at that moment when Russia changed to the system in AC, and in 1895 the city of Moscow granted the contract to the firm AEG to electrify the whole city, and in this way forming a monopoly. St. Petersburg, on the other hand, in 1886 had a single electricity supplier for only one section of the city until it thought differently and developed the philosophy of competition to boost electrification in the city at better prices with more efficiency and coverage, so that from 1908 electric technology began to expand in Russia beyond St. Petersburg and Moscow to cities such as Krakow, until in 1911 this city put into service its first plant in AC with its own distribution systems, and other communities such as Baku, Lodz, and Demo. Another factor that contributed to the slow electrical development in Russia was the slow demographic growth, since most of its important cities and industrial centers were located in the western zone of Russia, near the borders with Europe, while the east and northern regions of Russia were low populated and therefore lack of an industry that requires the electricity supply. It was until the beginning of the First World War when Russia accelerated its energy development in 1920 based on the recommendations of the Russian engineer Gleb Maximilianovich when he spoke to the Russian Congress about the need to accelerate the electrification to boost Russia as a political, military, scientific, and technological power in the world. During the First World War, Russia still depended on the supply of materials and electrical equipment from foreign coming from allied and neutral countries, but also on enemy countries. Due to this situation, in 1915, Russia began to put in place plans to promote its own technology and not depend on the outside. Although, of course, at first this was very difficult, in this same year, Russia nationalized the electrical systems installed and operated by foreign companies. In 1922, one of the most important power stations in Russia came into service, the Kashira plant located south of Moscow. Another character who pushed the electrical industry in Russia was Vladimir Lenin, who thought that regardless of the ideology that the Russian engineers followed, electricity was the vital factor for its technological development and as a society. So, in 1920, Lenin instrumented and supervised the Goero plant, which was a prototype plant to achieve the electrification of Russia and was approved by the Congress in 1921. The Goero plant consisted of a plan of 10 to 15 years, including the construction of 30 regional generation plants plus 10 mega hydroelectric projects. By 1930, 3 of those 10 proposed mega projects were built: the Volkhov, Sber, and Dnieper power plants. For the period from 1937 to 1940, the goal of the Goero plant was achieved, leading Russia to have a solid and efficient electric system. At the end of the Second World War, Russia will become the second producer of electricity in the world after the United States, and in 1950, it became a pioneer in the generation of electricity based on nuclear fusion, with the construction of the Obsnik nuclear power plant and the largest hydroelectrical plant in that time, the Krasnoyarsk power station. So this was a very short panorama how this region of Russia or Soviet Union was developed. So I hope to have the progress of your company for the next video. Transmission Lines Engineering TV, training to power the war.